Assalamu alaikum and good morning. This is video number 4 to 7, and in this video I'm going to use nonlinear least squares estimation, that is the NL command in Stata. NL command in Stata fits an arbitrary nonlinear regression function by least squares. So what does this mean and how we will do it? I'll give you an example. We define the nonlinear function to be fit by NL command by using a suitable expression. And as an example, in this video, I would like to fit the constant elasticity of substitution production function with NL command using Stata software. Let me give you some introduction of the constant elasticity of substitution production function, which is a new classical production function that displays constant elasticity of substitutions. In other words, the production technology has a constant percentage change in factors, that is labor and capital proportions, due to percentage change in marginal rate of technical substitution. The two-factor capital labor CES production function, which was initially introduced by Robert Solow and later made popular by Arrow, Shenry, Minhas and Solow. And this production function, the general form of CES production function, is given by this equation or this function. In this function, Q is the quantity of output, F is a factor productivity or efficiency parameter, A or alpha in this production function shows the share parameter, so this is a distributive parameter. K and L are the quantities of the factors of production of capital and labor respectively. Rho is a substitutive parameter and it is equal to sigma minus 1 divided by sigma, whereas elasticity of substitution is defined as sigma, that is equal to 1 divided by 1 minus rho. And V in the above production function is the degree of homogeneity of the production function, and it is equal to 1. Then there are constant return to scale, and if V is less than 1, there are decreasing return to scale, and in case of V greater than 1, there are increasing returns to scale. So this is a brief theory of the CES production function. As its name suggests, the constant elasticity of substitution production function exhibits constant elasticity of substitution between capital and labor. Lim to F, linear and Cobb-Douglas production functions are special cases of the CES production function. If rho approaches 1, we have a linear or a perfect substitutes function. In that case, the isoquant will be a linear or a perfect substitute case. If rho approaches 0 in the limit, then we have Cobb-Douglas production function, and if rho approaches negative infinity, we get the Lim to F or perfect complements production function. In order to estimate the CES production function, we specify the above equation as follows. Here, this is natural log of output for the firm I, for the ith firm. This is the constant of the production function, and K and Li are the capital and labor used by the ith firm respectively. Epsilon I is the error of this regression. As I mentioned, delta in this production function is the share parameter, whereas rho is the substitution parameter, and this because rho appears in the denominator of a fraction, 0 is not a feasible initial value. for constant elasticity of substitution production function rho is equal to 1, and that is a reasonable choice. And setting delta equal to 0.5 implies that labor and capital have equal impact on output, that is they have 50% share in the total output respectively, which is a reasonable choice for an initial value. And in order to do this, we will type this command for the estimation of the constant elasticity of substitution. Ladies and gentlemen, first I will explain the methodology of nonlinear least square estimation, and later on I'll use some data, example data set from Stata, and I'll estimate this function practically. Here is the output. I have already estimated that, but I'll show how to do this. And this is the estimation of the elasticity of substitution, and I will now estimate this in Stata. To do that, finally I will get the estimation of beta naught, that is the constant, which is equal to the natural log of output for the ith form, and this is the 0.5 for lambda, and rho is -1, and so a good initial value for beta naught is the mean of the right hand side of this equation 2, and we will ignore the epsilon I. In order to show that, let me go to Stata, and I have opened my file already here. These are the three variables. One is the capital, this is labor, and this is log of output, and I can show this in the data editor. These are the various values. The first variable is capital, the second variable is labor, and finally we have log of output, and there are 100 observations for this data set. So let me do this. So first of all, I would like to estimate this function that I just explained. So this is the command for estimating the constant elasticity of output, constant elasticity of substitution. So these are the iterations. There are seven iterations, and these are the residual sum of squares. This is the analysis of variance. So this is regression sum of square or model sum of square. This is residual sum of square. This is total sum of square. This is mean sum of square for the model. This is for the residual, and this is total, and the total number of observations. These are the model level statistics. Total number of observations 100. R squared value is equal to 0.756, and adjusted R square is 0.751. Root mean square error is 0.55, and this is the coefficient for the constant, and this is the coefficient. This coefficient shows rho, that is the substitutive parameter, and this coefficient shows a delta parameter, and delta parameter is the distributive parameter. It shows the share of the various factors of production in the total output. These are the standard errors, these are the t values, and the three coefficients are significantly different from 0. They are statistically significant. These are the 95% confidence interval. Now in the note it says that parameter beta naught is used as a constant term during the estimation. So this is used as a constant term in the during the estimation. Let me also explain this a bit. The command NL, that is nonlinear least square estimation, will attempt to find a constant term in the model, and if one is found, it is mentioned at the bottom of the output like this. NL found beta naught to be a constant because the partial derivative of log of QI with respect to beta naught has a coefficient of variation which is less than EPS. EPS means encapsulated postscript in the estimation sample. After this, we will estimate the elasticity of substitution for the constant elasticity of substitution function and that is equal to sigma, which is equal to 1 divided by 1 plus rho. And having fit the model, we can use this command nlcom to estimate it. So how can we do that? For that, I'll give this command nlcom 1 divided by 1 plus this coefficient divided by rho. So if I press this, it will estimate for me the elasticity of substitution between labor and capital, or capital and labor. So here is the coefficient for elasticity of substitution, and that is equal to 0.4189372. This is its standard error, and this is its z value, and this is the probability value. So since this is a less than 0.05, so this coefficient is highly statistically significant. So after that, I'll explain this, and I do this for you so that you could see the explanation. Now the nonlinear, the NL command output closely mimics that of the regress command in the ordinary least square, and the R square, the sum of squares and similar statistics are calculated in the same way that the regress function calculates in OLS, and I can show these to you. You can see these are the R squared, adjusted R square, and similarly number of observation, and also in the above equation we have R squared, we have adjusted R square, we have root mean square. All these model level statistics are given, but there is one difference. In case of this, we don't have the model F statistic. So unlike regress command, the NL command does not report a model F statistic, because a test of the joint significance of all the parameters except the constant term may not be relevant in a non-linear model. So that is why this model doesn't give us the model F statistic. So ladies and gentlemen, this is how we estimate constant elasticity of substitution, or constant elasticity of substitute production function, and this is the interpretation and explanation of this function. I also gave you some theoretical foundation of the constant elasticity of substitution production function. I hope this was useful for you. Thanks for stopping by, and let me share with you final stage of this, the final result. So in the above example that I just did it, reasonable initial values for sigma and rho are 0.5 and 1 respectively. This we assumed in the constant elasticity of substitution production function. So based on those values, equation number 1 that you saw earlier can be written as this, and then beta naught, that is the constant of this model, is equal to log of output for the ith form plus the right hand side where the delta is equal to 0.5, 1 minus delta is also equal to 0.5, and this is the value, since this is minus rho, so this is minus 1 because the value of rho was assumed as 1, and this is the error term. So a good initial value of the beta naught is the mean of this right hand side of equation 2, and when we ignore the error term. So we will ignore this because in the estimated regression this is this vanishes automatically. So beta naught is equal to natural log of output for the ith form plus natural log of 0.5 k raised the power minus 1 plus 0.5 L raised the power minus 1. So this gives us the mean of the right hand side, and that is equal to the constant of this equation. If you haven't yet subscribed to this channel, kindly do subscribe to the channel, and do not forget to click on the bell icon so that you can quickly receive information about my other variables that I will upload for you. Thanks for watching. Kindly share various videos of this channel in various WhatsApp groups. Thanks for